Today we'll be looking at combinations of transformations. When looking at transformations and we're looking at combinations of transformation, order is really important. So we need to follow the RST rule, which is reflections, stretches, and then translations. Although not necessary, it is often helpful to make a chart to help keep things organized. So what I want us to do in our first example is to sketch y equals x squared and y equals negative x minus 2 all squared plus 1. So looking here, what is our parent function? So the parent function is that base function we're discussing, which is y equals x squared. So we're going to follow a couple of different steps while we're going through each example here. So step 1, we want to factor whatever is in front of the x inside the brackets. So what that means is we need to factor out a negative x, or sorry, just a negative from the x, so we are left with x plus 2 all squared plus 1. Our second step is we want to describe the transformations in words. So our first thing that we're discussing is that we have a horizontal reflection. The second thing is that we are translating, so translate it 2 units left. And the last thing that we can say is that we're going to translate, so translate it 1 unit up. Now in step 3, we're going to construct a table of values of the key points of the parent function. And then we're going to use our columns here, our RST columns on either side. And we're going to use that so that we can graph easily our transformed function from our parent function. So to begin here, we're going to start with our y equals x squared. I know we don't need to actually know our table of values because we all memorized our base functions already, but using an RST table, especially when we're combining functions, is really helpful to keep everything very clear, and that way you don't actually have to graph a numerous different transformations. So we're going to start at negative 3 for our x and go all the way up to positive 3. So remember that when we're choosing our x values, those x values are our independent values. So they don't matter on anything else. Where our y is our dependent variables, which they depend on whatever x is. So when x is equal to negative 3 and we sub that into our y equals x squared, we're going to get that y is equal to 9. When it's negative 2, 4, negative 1, 1, 0, 0, and then we have 1, 4, 9. So we could graph this. So we have 0, 0, 1, 1, and 2, 4. Similarly on the other side as well of the origin. And that there is our parent function of y equals x squared. Now what we're going to do next is we're going to actually perform our RST. So again, R stands for reflections, S stands for stretches, and T stands for translations. So in our function here, our first thing that we had stated was that we have a horizontal reflection. Now recall from our horizontal reflection lesson, horizontal reflections affect the x value, and therefore we're going to multiply our x's by negative 1. Our next thing that we're looking at is that we're going to go left 2 units. Again, when we move left or right, that again is going to affect our x values, and that is a translation. We don't have any stretches here, so in our translation we're going to minus 2. And then our last thing was that we were moving up 1 unit. So we're translating 1 unit up. We have no vertical reflections or stretches, so that is all the information that we need to do. So let's first deal with our x. So we have our reflections here. We're going to multiply each x value by -1. So we have 3, 2, 1, 0, -1, -2, and -3. Now the next thing that we want to do after the reflection is -2 from each value. So we have 1, 0, -1, -2, -3, -4, and -5. So you notice that we're following our order where we did our reflections, we had no stretches, and then we did our translations. Now for our y, the only thing that we have is a translation. So we're going to add 1 to each y value. So we have 10, 5, 2, 1, 2, 5, 10. Now we have our values. So what do we do with these values? Well, these are now your x's and these are your y's for your new function. So what you're going to do is you're going to graph your first one at 110. That value is a little high, so we're actually not going to graph that one just because our axis here doesn't go up to 10. So 0, 5, so we can graph that. So we're not going to move left or right at all, just up 5 units. Our next point is -1, 2. So left 1, up 2. The next one we have is -2, 1. So left 2, up 1. And the next point we have is -3, 2. So left 3, up 2. And the last point here that we're going to graph is -4, 5. And then we're just going to connect those points. And that is going to be our y equals -x plus 2 all squared plus 1. Now if you wanted to go and check if you did this right, if you want to pause the video, go to Desmos. Desmos is an online graphing calculator. You could then go and put our whole function in there and see if we have plotted our points right. So now, looking at example 2, we want to sketch the parent function and the transformed function. So looking at this, we have y equals 1/2 times x plus 3 all squared plus 3. So what is our parent function here? Well, since we have a squared there, we know our parent function is y equals x squared, so it's just another quadratic. So step 1, factor out whatever's in front of the x inside the brackets. Now, is there anything in front of the x inside the brackets? No, so we don't actually need to factor anything out, so I can just rewrite this as above. Step 2, we want to describe the transformations in words. So our first thing that we have here is a vertical compression by a factor of 1/2. Next thing is our 3 inside the brackets, so we know that it's being translated. 3 units left. And the last thing is our 3 that is added, so we know it's translated 3 units up. So now we're going to go ahead and do our RST table. Again, we're going to begin with our parent function, y equals x squared. So we're going to again start at -3 and go up to positive 3. So this step we did in our previous example. So now we're going to look at which transformations we have. So our first one is that we know it's being vertically compressed by a factor of 1/2. When it's vertically compressed, it's going to affect our y. So in our stretch column here, we're going to multiply by 1/2. The next thing that we know is translated 3 units left. If it's moving left, we know we're going to minus 3 from our x. And our last transformation is that it's translated 3 units up. So we're going to add 3 to our y value. So let's first deal with our x values. So from each x value, we're going to minus 3. We have no reflections or stretches that we need to work with. So negative 3 minus 3, we have negative 6, then negative 5, negative 4, negative 3, negative 2, negative 1, and 0. Now for our y's, our first thing that we need to do is we need to multiply by 1/2. So 9 times 1/2 is 9/2. 4 times 1/2 is 2. 1 times 1/2 is 1/2. 0 times 1/2 is 0. 1 times 1/2 is 1/2. And 4 times 1/2 is 2. And 9 times 1/2 is 9/2. Now we're going to add 3 to each of those values. Remember, when we're adding to a fraction, if we're adding 3, so this would be 9/2 plus 6/2. So when we do that, we're going to have 15/2. And then 5, and then 7/2, 3, 7/2, 5, and 15/2. So the first thing we want to do is we want to graph our parent function. So that's our base function of our quadratic, something that you should be able to do really quickly by now. And label y equals x squared. Our next step is that we're going to graph our x and y's. So these are our new x values and these are our new y values. So what I'm going to do, I'm going to graph all my y values that are whole numbers. It's just because it's easier. So I'm first going to graph negative 5, 5. So it's a little bit off of our axes here, and up 5. So we're going to have a point up here. The next point that I'm going to graph is our negative 3 and 3. And the last point that I'm going to graph is negative 1, 5. And then I'm going to connect these and label y equals 1/2 x plus 3 squared plus 3. Now remember, you can go and pause the video now and check on your Desmos online calculator if you'd like to make sure that we have graphed this properly. Now looking at example 3, we want to sketch the parent function and the transformed function y equals 3 root negative 2x minus 4 minus 1. So what is our parent function? Since we have a root there, we know that our parent function is y equals root x. So we're going to use that as our base function and graph that in step 3 and use it when we're doing our RST tables. Step 1, we want to factor out whatever's in front of our x inside the brackets. So you notice here we have a negative in front of our x, and we also have a 2 in front of that x. So we're going to factor out the negative 2 from both the negative 2x and the negative 4. So we have y equals 3 root negative 2x. Forgot to write that. So negative 2x times x plus 2. And then that will be minus 1. So now we do that so that we can actually see what the transformations are exactly. So our first one, we look at 3. So that 3 is telling me I have a vertical stretch by 3. Now this negative right here is telling me that we have a horizontal reflection. The 2 is telling me that we have a horizontal compression by a half. This 2 here tells us that we are moving left 2 units, and this -1 means we're moving down 1 unit. And now in step 3, we're going to construct an RST table and graph. So the parent function we're working with is our y equals root x, and with that we need to do a table of values. Remember, we're going to start at 0. The reason being is because if we put a negative value underneath the square root sign, that gives us an imaginary number, and we know already that can't exist. So we have 0, 1. We're also going to choose perfect squares, so 4, 9, 16, 25, and 36. So these values are getting really high, but it's going to give us a good idea of what's happening with our transformed graph here. So when you sub in 0 in for x, you get 0 for y, and then 1, 2, 3, 4, 5, and 6. So now we're going to look at the fact that our transformations, our first ones are vertically stretched by 3. So if it's vertically stretched by 3, that's affecting our y value. So in our stretch, we're going to multiply by 3. The next thing we see is that it's being horizontally reflected. So if it's horizontally reflected, it's affecting our x value. So we need to multiply by -1. The next thing that we see is that we have a horizontal compression by a half. So we know that we need to multiply our x values by a half. Then we also see that it's left 2 units. Again, it affects our x value, so we -2. And then down 1 unit, so that affects our y values, so -1 in our translations. So let's first deal with our x's. So we're first going to deal with the reflection, so each value is all going to turn to negative. So 0, -1, -4, -9, -16, -25, and -36. Our next step is we're going to multiply each thing by a half, since we know that it's horizontally compressed by a half. So 0, -1/2, -2, -9/2, -8, -25/2, and -18. And then the next step is to -2 from each of the values. So -2, -5/2, -4, -13/2, -10, -29/2, and -20. If you need to do some side work to be able to figure out when you're minusing or when you're multiplying, please do so. Now let's deal with our y's. So we're going to multiply each value by 3. So 0 times 3 is just 0. 1 times 3 is 3. 6, 9, 12, 15, 18. Next step is we are going to -1 from each value. So -1, 2, 5, 8, 11, 14, 17. So now we have our x and y values for our transform function. First step, however, is that we're going to graph our parent function. So 0, 0, 1, 1, and 4, 2. And that's our y equals root x. Now we're going to go ahead and graph our new one. So remember, these are our x values and our corresponding y values for each coordinate. So the first one we have is -2, -1. The next point we have that I'm going to look at is -4, 5. And we could look at more, but it will be off of our graph, so we're just going to graph that. So you can see quite easily that this is really being stretched and very large compared to our original. And we can label, so y equals 3 root -2 times x plus 2 minus 1. So now in example 4, we want to sketch the parent function and the transform function. So our transform function is y equals -2 times 1/3 x plus 2/3 all cubed plus 3. So you notice that it has the cubed here. So therefore our parent function is a cubic. So our parent function is y equals x cubed. 3. So now what we want to do is we want to factor whatever is in front of the x inside the brackets. So we have y equals -2 times, we're going to factor out 1/3, and we're left with x plus 2 all cubed plus 3. So now we want to describe our transformations in words. So the first one, you notice that we have a reflection because it's negative. So we have a vertical reflection. We also have a vertical stretch because of the 2. So a vertical stretch by 2. Then we have 1/3. So that's a horizontal stretch by 3. We have plus 2 inside the brackets, so we know that it's moving left 2 units. And then we have plus 3, so we know it's moving up 3 units. So now we're going to go ahead and start to construct our RST tables. So beginning with our parent function, y equals x cubed, we're going to start with -3 and go up to +3 for our x's. Now we sub in -3, -3 cubed would give us -27, and we do the same thing with -2, giving us -8, and so on. So -1, 0, 1, 8, 27. Sorry, that should be a 3, not a 5. I don't know why I wrote that. Sorry about that. So the next thing is we're going to look at each of the transformations. Our first one is that it's vertically reflected. So if it's vertically reflected, we know it affects our y values. So we're going to multiply everything by -1. Now our next one is that it's vertically stretched by 2. So it's again affecting our y values, so you're going to multiply by 2. Our next transformation is that it's horizontally stretched by 3. So you're going to multiply your x values by 3. Then we know it's moving left 2 units, so -2. And then we know it's moving up 3 units, so +3. So let's go ahead and deal with our x's first. So we're going to multiply each x value by 3. So -3 times 3 will be -9. -2 times 3, -6, and so on. So we get -3, 0, and then 3, 6, 9. Now we're going to take each of those values and -2. So -9 minus 2 is -11. -6 minus 2 is -8. Then we have -5, -2, 1, 4, 7. So now let's go ahead and work with our y values. So we have negative 27, we're going to multiply that by negative 1, so we have positive. So all of our y values are going to change from negative to positive and positive to negative. So then 8, 1, 0, negative 1, negative 8, negative 27. Now we're going to take each of the values of y and multiply by 2. So 27 times 2, 54, 8 times 2, 16, 1 times 2, 2, 0, negative 2, negative 16, negative 54. And the last thing that we're going to do is add 3. So 54 plus 3 is 57. 16 plus 3 is 19. 2 plus 3, 5, 3, 1, negative 13, and negative 51. So now let's first graph our parent function. So it's going to be off the chart a little bit. So let's first look at negative 2, negative 8. So if we graph that, this only goes to 4, so it's hard to get large graphs sometimes. So it will be far down, but just so we get an idea there, I graphed it quite a far way down there. Then we have negative 1, 1, 0, 0, 1, 1, and 2, 8. So somewhere up there. Now we all know that when we're graphing a cubic, what happens is it creates an S pattern. So this is our y equals x cubed. Now we're going to go ahead and graph our transform function. So these are our x values, and these are our corresponding y values. Obviously we're not going to graph each value, so let's start with negative 5, 5. So over 5 left from the origin, up 5, so it's a little bit off of our graph still. Next point is negative 2, 3. So over 2, up 3. Next point is 1, 1. So that point is shared with our parent function there. And then we could go and graph for negative 13, but that's going to be a lot further down. So you notice here that this has got a little bit wider and also stretched. So this is our our transform function, y equals negative 2 times a third x plus 2 all cubed plus 3. And now for the last function. Our function is already going to be drawn in for us. We will do that in a minute. And what we're doing is we're just performing the transformations on the function that's given. So what we have here is y equals a half f at 2x minus 1. So looking at this, we want to factor whatever's in front of our x inside the brackets first. So we need to factor out that 2. So what we have is y equals a half f at 2 times x minus a half. So now let's state what our transformations are. So this half here tells me that we have a vertical compression. So vertically compressed by a half. This 2 here tells me that we have a horizontal compression by a half, and this minus a half tells me that we are going to move a half unit right. So now let's look at our function and actually do an RST table. So our parent function is shown here, And our points for our parent function, let's look at each coordinate. So our first coordinate, starting from the left, is -4, 0. Our second coordinate, moving to the right, is going to be -2, 4. Our next one is -1, 2. And then we have 1, 2, and 3, 0. Now looking at our transformations here, we first see that it's vertically compressed by a half. So that affects our y value. So we're going to multiply by a half. And then we know we have a horizontal compression by a half, so it affects our x value, so times a half. And then we also know that it's moving a half units, right? So we're going to add a half. So let's deal with our x's first. So we're first going to multiply by a half, so -4 times a half is -2. -2 times a half is -1. -1 times a half is negative a half. 1 times a half is a half. And 3 times a half is 3/2. And now we're going to go ahead and add a half. So -2 plus a half is going to be -3/2. -1 plus a half is going to be -1/2. -1/2 plus a half is going to be 0. A half plus a half is going to be 1. And 3/2 plus a half is going to be 2. Now for our y values, we're going to multiply each y value by a half. So 0 times a half is 0. 4 times a half is 2. 2 times a half is 1. 2 times a half is 1. And 0 times a half is 0. So now what we're going to go ahead and graph our new x values and our corresponding y values. So our first one is -3/2, which is 1.5 and 0. So it's going to be right on our x-axis there. Next point is -1/2, 2. So we have that point right there. Our next one is 0, 1. And then we have 1, 1, and 2, 0. So now we can connect these following the same pattern as our parent function. And that's our transform function there.